Section 2.4, Statistical Graphics. Here we will go over some of the basic types of graphs you see when visualizing statistics. A frequency polygon uses line segments connected to points located directly above class midpoint values. A frequency polygon is similar to a histogram, except it uses line segments instead of bars. So here we have a histogram. If we draw a line segment to the middle of each bar's height, we create a frequency polygon. Of course, imagine this graph without the bars now. As another example, here we have an actual frequency polygon without the bars. An ogive is similar to a frequency polygon, except it depicts cumulative frequencies. Recall our discussion about cumulative frequency distributions. You should see a connection to ogives. Dot plots consist of graphs in which each data value is plotted as a point, or dot, along a horizontal scale of values. Dots representing equal values are stacked. So on this dot plot, each dot may represent one person, 10 people, or 100 people, etc. Bar graphs use bars of equal width to show frequencies of categories or categorical data or qualitative data. The vertical scale represents frequencies or relative frequencies. The horizontal scale identifies the different categories of qualitative data. Many times, two or more sets of bars are used to compare different data sets, such as in the graph you see here. At first glance, a bar graph and a histogram might appear to be the same thing. The main difference that you should focus on is that a histogram depicts quantitative data along the horizontal axis, and a bar graph depicts qualitative data along the horizontal axis. A pareto chart is essentially a bar graph, but the categories are arranged so that the heights of bars are in descending order. A pie chart is a common way to represent categorical data. Each category is represented by a slice, and the size of that slice is proportional to the frequency of the category. In this example, Ontario makes up the largest fraction of Canada's population, so Ontario takes up the largest slice of the pie. A scatter plot is a plot of paired quantitative data with a horizontal x-axis and a vertical y-axis. The horizontal axis is used for the first variable x, and the vertical axis is used for the second variable y. With enough data, a pattern may emerge, helping us understand some aspect of that data. For example, consider this scatter plot. The x variable is the weight of pennies sampled, and the y variable is the year those pennies were created. The scatter plot clearly shows there is something interesting happening, with a large gap between the two groups of dots. Let's consider what's happening. The cluster of dots in the lower right all have weights that are high and years that are low, whereas the cluster of dots in the upper left have lower weights but higher years. An explanation for this gap could be that at some point around 1980, the U.S. Mint began creating pennies out of a lighter weight copper mix, whereas prior to 1980, pennies were made out of pure copper, thus making them heavier. Time series graphs depict changes in some variable over time. A common time series graph is of the stock market. This graph shows how the price of the Dow Jones Industrial Index changed over the course of 3 days, with changes recorded every second during that time. You may have noticed that although the graphs we talked about in this section are pretty common methods of visualizing statistics, they are not all that interesting or engaging. Somewhat boring, really. There is a great need for graphic designers with the ability to come up with creative ways of visualizing data. One of the more interesting magazines I have found for visually interesting depictions of studies and experiments is Wired magazine. Here's one good example looking at the percentage of new foods used in each the percentage of new foods that use each food dye. This could have been represented by a bar graph, pie chart, pareto chart, but clearly the designer found a much more interesting and engaging way of depicting the same information. As another example of the way Wired magazine makes data interesting to look at, we have a time series graph here comparing two different variables. Lastly, this is a time series graph where a time span of 1 second is spread out over the page. Each dot above or below the line represents purchase or sales of shares of energy sector stocks. Notice that a fraction of a second before the U.S. Energy Information Administration publishes its natural gas storage report, there are several trades. The conclusion here is that somebody is getting this information a fraction of a second earlier than everyone else, which suggests that they have an unfair advantage in the marketplace to buy stocks they know will increase in price. These are just a few examples from one magazine, but there are several out there. I encourage you to think about, as you look through magazines, newspapers, on the web, to think about how data is represented and how creative the designer was to depict that information.